I think it will be fun to compare AWS's costs to DigitalOcean. Technically, they're not really in the same league, but it makes for a good lecture because DO is commonly known as being one of the cheapest cloud providers while offering reasonable performance. I'm very confident I could run the same Rails demo application on DO using one $20 a month box. That would give you 2 gigs of RAM and 2 CPU cores with more than enough disk space and bandwidth. Then we could run 2 copies of the Rails application, which would be 600 megs of RAM combined. Then we'd add sidekicks into the mix for another 150 megs of RAM. And finally, we'll quickly estimate that Postgres, Redis, and Nginx will each use about 100 megs of RAM. That should give you plenty of room to cache things. That brings us to a grand total of 1 gig. On a 2 gig box, that gives us plenty of room for the operating system's resources and room to breathe. Now you need to ask yourself, why pay $75 a month on Amazon when you can do the same thing for $20 a month on DO? The answer is really simple. On Amazon, scaling out is super simple. ELB takes care of draining connections and making sure traffic isn't served to instances that are down. Amazon ECS gives us service files that can be configured with a minimum healthy status for that service. That will allow us to perform rolling restarts when we push new builds. With the DO approach, you would need to set up your own load balancer. Nginx can do this, and so can HA Proxy, but how are you going to update the config in real time so that dead instances or processes aren't serving traffic? The answer is a lot of development time, because you're going to have to research how to do this and then implement it yourself. This might take 20 hours of your time, and if you value yourself at a modest $50 an hour, then we're talking about $1,000. It gets worse too, because you need to maintain all of this yourself instead of just hacking away on your app while letting someone else deal with load balancing. You might think to yourself, well, I don't need 2 app instances running on the same box. That's an awful amount of trouble for no benefit. Yeah, that might be true to some extent, but then you have to think about downtime. If you don't have 2 instances of your app running, then your app is going to go down when you push a new build. This isn't a huge deal for most apps because really, we're talking about 2 seconds of downtime, and even if you deployed a few times per day, that's not a big deal. However, I do want to point out that having 2 instances of your app running opens up a lot of possibilities. For example, you could do canary deployments. That means you could push out a new version of your application to production and limit it so that only a small percentage of your traffic gets routed to the new version. Then, when you're happy with the new version on a small subset of your traffic, you can deploy it to everyone else. That's a pretty cool feature to have at your disposal. Another advantage is zero downtime deploys because you can just do rolling restarts. I know certain app servers like Puma have clustering mode and ways to do that sort of thing internally, but that's kind of a hacky solution, and it's much more limiting than a real load balancer. Another advantage is being able to do blue-green deployments. This typically means that you will have one version of your application that's being served to everyone, while the next version is running alongside it but isn't being served any traffic. Then you just make a simple DNS switch to route traffic to the new version when you're ready, and if things go up in flames, then you're a simple DNS switch away from routing traffic to the old version. This is a very effective way to minimize risk. Of course, your throughput is cut in half since only one instance will be serving traffic most of the time, but if your app requires super fast rollbacks and uptime is a serious concern, then it's an effective strategy. With multi-instance advantages out of the way, let's talk about RDS and ElastiCache. We don't need to worry about maintaining the servers handling our data because part of the advantage of using those services is that Amazon deals with it for us. Amazon will also back up your data, and recovering from a catastrophic event is pretty painless. You could easily roll your own backup solution, and if you took my other Docker course, you would have remembered going over that because we built a cron-based backup solution. There's nothing wrong with that, but if you don't want to use your own workstation as a backup server, now you need to write some custom script to upload it to S3 or some other location. Long story short, it's more work for you. There's other advantages too, such as when you grow to a much larger scale, you can implement auto-scaling groups. This isn't something you need from the get-go, because it's not like you're going to need to spin up and down hundreds of servers from day one, but it's very nice to have at your disposal when you need it. I feel like the added costs of AWS are justified. I have a feeling Amazon will even continue cutting their prices because they need to stay competitive with Google's cloud services, but if you're looking to run an untested app idea, it may very well be worth the extra cost over DO if you're on a limited time budget, because developing your app is much more important than developing your own infrastructure at the early stages. With that said, you can actually match DO's prices on AWS due to the free tier. That's what we're going to talk about in the next lecture. I'll see you then.